This question is about chromium and its compounds. Give the full electron configuration of a chromium atom. So the first thing you're going to want to do is go to the periodic table, look up chromium, find out that it has atomic number 24. Okay, then you do have to remember something. So you have to remember that chromium and copper don't have the electron configuration you would expect. Remember the little rhyme, don't come a cropper, remember chromium and copper. And the difference is, instead of filling the 4s, they have a half full 4s subshell, and then that impacts whether the D subshell is half full or full, depending on whether it's chromium or copper. This is a more stable electron configuration. So we're trying to put 24 electrons in. We're going in order, 1s2, 2s2, 2p6, and into the third shell, 3s2, 3p6. That's the first 18 electrons. Now normally we'd then fill the 4s, but for chromium and copper we only half fill the 4s, and then we're going to go into the 3d. But notice how I left a gap, wrote the 4s and then filled the gap with the 3d. I'm going to go back and count up the remaining ones. It's a half full subshell, 3d5. An atom has 2 more protons and 3 more neutrons than chromium 52. So if we have a look at this, we'd have had 24 protons, and then 52 subtract 24, which would be 28 neutrons. And this is an atom, so we're not worrying about charge on the electrons here. So if we're going to have 2 more protons, we're going to have 26 protons. And if we're going to have 3 more neutrons, we're going to have 31 neutrons, and add that to 26 to get the mass number. We're going to be at 57, and that is going to, if we look up number 26 in the periodic table, we find out it's iron. Okay, a sample of chromium contains 4 isotopes. Determine the percentage abundance of the 4th isotope. So there's another isotope here with an abundance of X and a mass number, let's just call it A for now. Determine the percentage. Now remember that percentages add up to 100. So if we do 100, subtract what we've got, we'll see what we've got left. So we do that on our calculator. And I've got 3.6% left. So the percentages have to add up to 100. Then we know that the relative atomic mass is the sum of the masses times the abundance divided by the total abundance. So we know that 52, let's do that here, 52.09 equals 52 times 82.8 plus 53 times 10.9 plus 54 times 2.7 plus 3.6 times our unknown mass number, and all of that is divided by 100, total abundance. So we're going to do some rearranging. So if we type in some of these numbers on our calculator, 4305.6 plus 577.7 plus 145.8 plus 3.6 times our unknown, and then we do some subtracting to find our 3.6a equals 179.9. So our number A, if we divide that by 3.6, we're going to get 49.97. So it says show by calculation that this is 50. It does round up to 50 to the nearest whole number, mass number being a whole number. Next part of the question is about redox. So deduce the oxidation state of chromium. So 2 times some unknown plus 7 times, we know that oxidation state of oxide ion is -2 of oxygen, and that sum equals -2. So 2x equals 12. So our oxidation state for chromium is +6. Iodide ions can be oxidized to iodine. So iodide ions can be oxidized to iodine using dichromate 6 ions. So we want to do, first of all, the oxidation of iodide ions to iodine. So I- to I2. So first of all, balance the iodines, now balance that charge. Oxidation is loss of electrons. And now we need to do dichromate to chromium 3+. So rule number 1, balance the element undergoing redox. So we're going to balance the chromium by putting a 2. Now we're going to add water to balance the oxygens. So we'll need 7 waters. Then we're going to go back and we're going to add acid, hydrogen ions, to balance the hydrogens in the water. And then we're going to balance the charge by adding electrons. Now on the left hand side at the moment we can see, if I just do that in a different colour, we can see that we've got 2 minus and 14 pluses, that equals 12 pluses on this side. And here we've got 2 times 3 plus, that equals 6 plus on this side. So to get from 12 to 6, I'm going to need to have 6 electrons. And then we're going to use our answers to these two parts. And we see that we need to times our top half equation by 3 in order to balance the electrons. So I'm going to get 6i minuses. And we're going to get 3i2s. And not changing anything in the chromium half equation.